zero order rate equation. For a reaction A gives rise to products initially at T is equal to 0. Concentration of A is A and P is 0. At time T is equal to T, it is A minus X. It indicates X concentration decreasing A from small a concentration. And here product P value is X. For this equation, rate is equal to dx by dt. That is minus dA by dt with respect to reactant. I considering this equation as a first order, zero order. For a zero order reaction, rate R is equal to K into concentration of A power 0. And it is a rate expression, and it is also for the zero order reaction. I comparing 1 and 2. Both the rates are equal. It indicates minus dA by dt is equal to K into concentration of A power 0. It is the change in concentration, and with respect to zero order A power 0. Separate the concentration terms. A power 0 is value 1 minus dA by dt is equal to K. And here minus dA is equal to K into dt. It is a differential rate equation, rate expression. And integral rate expression is minus integral of initial concentration is A and final concentration is A minus X, that is dA, and K into integral of dt. Initial time t is equal to 0 and final time t is equal to t, that is dt. Integral of dx is equal to x, then integral of dA is equal to a. Integral of dA is equal to a, and substitute their limits. Initial value a and final value a minus x, that is equal to integral of dt is t. K is a constant, its integration is 0, or you can write K. T limits from 0 to T. 0 to T. In integral, substitute initial upper value minus lower value, and it is a negative value. Minus of upper value is a minus x minus lower value is a. Upper limit minus lower limit. And here K into initial time is 0, final time is t, and initial time is 0. By this, multiply with minus to this equation, minus a plus x plus a is equal to k minus t minus 0 means t into k, that is kt. Here this is the minus value and this is the plus value. Finally x is equal to kt. Here rate constant k is equal to x by t. It is the integral zero order of rate equation. So once again, it is an equation. A gives rise to P. At a time t, initial concentration of A is small a. After time t, it is A minus x. It is inner value and it is a higher value. Rate is dx by dt, and I am considering it is a zero order reaction. R is equal to K into A power 0. These two are expression for a rate, that's why these two values are equal. And a power 0 value is 1, that's why 1 into k. And here I am separating a terms and d terms and substituting integration values. Integral of a to a minus x and t 0 to t. Integral of dA is equal to a. Upper value is a minus x and lower value is minus a. Substituted a minus x minus a, and here also t minus 0. Finally we get a rate constant of a zero order reaction is k is equal to x by half-life of a zero order reaction. For half-life of a zero order reaction, initially for a zero order reaction k is equal to x by t. Half-life indicates initial concentration of A is converted to A by 2, half of the concentration. And initial time is T, half-life is for the completion of half of the reaction, that is T 50%. Initial concentration A and half-life is decreasing concentration of A is half. So substitute these value in integral rate equation of a zero order reaction. K0 is equal to, here x value is a by 2, that is half life, and t is t 50% or t50. From this value t50 is equal to, that is half life, a by 2 k naught. T half or t50 is equal to a by 2 k naught. It is the half-life of a zero order reaction. And next, order of the reaction. Order is the sum of powers of concentration terms in rate equation is the order of the reaction. So order is sum of powers of concentration terms in a rate equation. Rate equation is R is equal to K into A power M and B power N and so on, where M is equal to order of A and N is the order of B and M plus N is the total order. So in a rate equation, their powers is the order of the reaction. Powers of a concentration term in a rate equation is called order of the reaction. And next, units for the order of the reaction. Units for the order of the reaction is concentration power 1 minus n and time inverse. Concentration is molar power 1 minus 1 and time inverse, or in terms of number of moles, mole power 1 minus n and later power n minus 1 and time inverse, where n is the order. What are the order of zero order reaction? For a zero order reaction, units is zero order indicates n is equal to 0, substitute n value in this term, then units for zero order is concentration power 1 minus 0 and time inverse. 1 minus 0 indicates 1, then it is a concentration and time inverse, or mole inverse, mole and time inverse. In terms of number of moles n power 1 and liter power 1 time inverse. Substitute n value here. 1 minus 0 indicates 1, then m is remaining time inverse. And here also substitute in the place of n 0, then it is n liters time inverse. For first order reaction, first order indicates n is equal to 1 and their units. Substitute n value in this units. Here 1 minus 1 is 0. It is only time inverse. For a first order reaction, units is only time inverse. And second order reaction. For second order reaction, here n value is equal to 2. Substitute this value in units. N 1 minus n, where n is 2, that is units are concentration power minus 1 time inverse, mole power minus 1 time inverse, or in the place of this unit substitute n value is 2, then number of moles power 1 and later time inverse. So it is the order and units of order of the reactions. Zero order reaction. So previously we discussed about zero order reaction. Rate constant K naught is equal to A by 2 T half. Here T half is equal to A by 2 K naught. And rate constant of a zero order reaction is A minus X minus A by T. It is derived on the basis of integral rate equation. And here this total value is the decreasing, then minus A plus X minus plus A divided by T. Finally K naught is equal to X by T. It is the rate constant of a zero order reaction and half-life of a zero order reaction. In the case of zero order reaction, units for rate and order of the reaction is the same. For a zero order reaction, units is concentration power 1 minus n and time inverse. Here the n value is equal to 1, 0. Here n value is 0 indicates zero order reaction. Substitute n value 0, then units are concentration and time inverse. Then what is rate? Rate is change in concentration by time. It indicates a concentration time inverse. If the denominator is will come into numerator, that is inverse. That's why for a zero order reaction, units of rate and zero order reaction are same. And for a zero order reaction, rate independent on time and initial concentration. Initial concentration. And for a zero order reaction, T half is directly proportional to initial concentration of the reactant. From this we can write T half of A1 divided by T half of a second is equal to initial concentration A1 by A2. So it indicates half-life of a zero order reaction is directly proportional to its initial concentration. And for a zero order reaction, completion of the reaction taking place in 2 t-halves. 100% of the reaction taking place by 2 t-half. So in first t-half, half of the reaction will be completed, and another t-half, second half of the remaining reaction will be completed. That's why for a zero order reaction, 100% of the reaction is completed by the 2 t-halves. And for a zero order reaction, number of t-halves, percentage of reaction remaining, and percentage of reaction completed. In 1 t-half, half of the reaction is completed, that is 50% reaction completed. In 100%, 50 complete, remaining means 50% is completed. 50% of the reaction is completed. And the number of halves 1.5, it indicates 75% of the reaction is completed, and 25% of the reaction is remaining. 75% indicates that is 3 by 4, and 25% indicates that is 1 by 4. Number of t-halves is equal to 2. In first t-half, 50% reaction completed. In the second t-half, remaining 50% is also completed. Then percentage of reaction remaining is 0. Percentage of the reaction completed is 100%. So it indicates for a zero order reaction, 100% of the reaction completed in 2 t-halves, and percentage of the reaction remaining is 0. Half-life of a zero order reaction is 250. Calculate half-life when the initial concentration of reactant increasing by 2 times. Here half-life of a zero order reaction is directly proportional to initial concentration. Then t half of 1 divided by t half of 2 is equal to A1 by A2. It is the half-life when initial concentration is A1. It is the second half-life when initial concentration is A2. And in the question, 250 is the half-life of a zero order reaction. And then it indicates initial concentration is A. At that time, the half-life is 250. When reactant concentration increasing by 2 times, calculated 2 t half. Here, first half-life is 250. In that concentration is A. If the initial concentration of the reactant increasing 2 times indicates 2A. In that time, t half is A cancellation takes place, then cross multiplication, t half is equal to cross multiply, t half is equal to 250 into 2, that is equal to 500 seconds. In a zero order reaction, 4 reactant molecules are converted into 2. It indicates 50% of the reaction, that is t half. You have to calculate the time for conversion of 4 reactant molecules to 1. It indicates it is 75% completion. And for a zero order reaction, t x percentage by t y percentage is equal to x by y. Here t x percentage indicates in 2 seconds it consumes 50%. You have to calculate for 75% the time required is. 25 twos and 25 threes. Finally 2 by t is equal to 2 by 3. From these value t can be written as 2 into 3 by 2. By the calculation of 2 to it requires 3 seconds. So it is the based on diagrammatical representation. Let us see this diagram. Here 4 reactant molecules converted to 2. 4 converted to 2 indicates 50% and 4 converted to 1 indicates 75% completion. In this problem, in a zero order reaction, T 10% is given, that is 15 seconds. And calculate time for T 50% and 60%. For a zero order reaction, T x percentage divided by T y percentage is equal to x by y. T 10% is the 15 seconds. And you have to calculate T 50% at what time? By cross multiplication, x is equal to 10 into x is equal to 15 into 50, and here x is equal to 75 seconds. Similarly, you want to calculate T 60%. T 10% is the 15 seconds and T 60% is x. By cross multiplication, 10 into x is equal to 15 into 60. Here x is equal to 90 seconds. For a zero order reaction, A gives rise to product. The initial concentration of the reactant is 0.01 molar. After 10 seconds, the concentration of the reactant remaining is 0.08 molar. Calculate T half. For a zero order reaction, T half is equal to A by 2K naught. A is the initial concentration of the reactant and K naught is the rate constant. And here the rate constant K0 is the, for a zero order reaction, A minus of A minus x by T. Here A is the initial concentration, A minus x is the after 10 seconds remaining concentration of the reactant. Initial concentration of the reactant is given as 0.01 molar, and after 10 seconds the concentration of the reactant remaining is 0.08 molar divided by time in 10 seconds. Its value is 0.002 by 10, and that is equal to 0.0002. It may be represented as 2 into 10 to the power of minus 4. That is the rate constant based on zero order reaction, that is A minus of A minus x by T. And half-life of the reaction is A by 2K naught. A is the initial concentration, that is 0.01. It may be written as 10 to the power of minus 2 divided by 2 into K naught, rate constant of the zero order reaction for this problem is 2 into 10 to the power of minus 4. And this value is 1 by 4. By the calculation of 10 to the power of minus 2 divided by 10 to the power of minus 4, that is 10 square. 1 by 4 indicates 25 into 10 square. So it is the half-life of zero order reaction. Rate constant of a zero order reaction is 2 into 10 to the power of minus 2. Concentration of reactant remaining after 25 minutes is 0.5 molar. What is its initial concentration? So what is the relation between rate constant and concentration of the reactant for a zero order reaction? K0 is equal to A minus of A minus x by T. Here K0 is the rate constant, that is K0 is equal to 2 into 10 to the power of minus 2. And at 25 minutes, concentration remaining A minus x is 0.5. Substitute these values in the above formula. K0 is equal to A minus of A minus x by T. Here you have to calculate initial concentration by the solving this equation. T K0 into T is equal to A minus of A minus x. From these K0 into T, this minus of A minus x will come into right hand side, that is plus A minus of A minus x is equal to A. And finally initial concentration A is equal to rate constant 2 into 10 to the power of minus 2 into time 25 minutes plus concentration remaining after 25 minutes is 0.5 molar. So here 25 into 2, that is 50. 50 into 10 to the power of minus 2 into 0.5. For this 0, remove 0.5 and this value is 5. 5 into 5, 25. 25 into 10 to the power of minus 2 is the its initial concentration. Let us see here calculation, one of the mistake was done, that is its value is positive, not a multiplication. So here this value is positive and 50 into 10 to the power of minus 2 can be written as 0.5 plus 0.5, that is equal to 1 molar concentration at initially.
Carbonyl compounds, aldehyde and ketone are called carbonyl compounds. It is an aldehyde. It has one double bond oxygen and hydrogen. Aldehyde. It is ketone. It has one double bond oxygen and two alkyl groups. It is ketone. In aldehyde, functional group has 1, 2, 3. 3 sigma bonds and 1 pi bond. In ketone, functional group has 1, 2, 3. 3 sigma bond, 1 pi bond. And it has 0 lone pairs. Totally 3 sigma bonds plus 0 lone pairs indicates it is sp2 hybridization. And here also total sigma bonds and 0 lone pairs, total 3, indicates sp2 hybridization. Both the functional groups are in sp2 hybridization and it is trigonal planar geometry. Both the functional group has trigonal planar geometry and bond angle is 120 degrees. It is the basic information about the aldehydes and ketones. And next, aldehydes and ketones exhibit some isomers. In isomers, both aldehydes and ketones exhibit chain isomers. Chain isomers has different in their carbon chain. And for example, aldehyde, I am taking with 4 carbons aldehyde, it is butanol. Butanol. Al is the suffix of the functional group. But indicates it has 4 carbons. And it can be written as isobutanol. Isobutanol. In this compound, straight carbon chain has 3 carbons and 4th carbon is present on the second carbon. It indicates it has one branching at second position. And here 4 carbons are present in straight line. Here 3 carbons are present in straight line. That is the difference in carbon chain. Then these are chain isomers. Similarly, ketones also exhibits chain isomers. In straight chain carbon, there is a 5 carbon atoms. It can be also written as 3-methyl butanone, and it is 1, 2, 3, 4, 5. In these two compounds, ketonic functional group has 5 carbons in straight line, 4 carbons in straight line. That is the difference in the carbon chain. Then aldehydes and ketones both exhibits chain isomers. It is about the chain isomer. And next one, functional group isomers. Functional group isomers indicates, I am taking for example C3CH2 C double bond OH. C double bond OH indicates an aldehyde, and it can be also written like this structure. Here C double bond O containing 2 alkyl groups, it is ketone, and it is CH2 double bond CH OCH3. Oxygen has 2 alkyl group, it is ether, and CH2 double bond CH CH2OH. Due to OH group, it is alcohol. Here this compound has molecular formula containing 3 carbons and 3 plus 2, 5 plus 1, 6 hydrogens, 1 oxygen. And this also has C3, H3 plus 3, 6 and 1 oxygen. These two compound has the same molecular formula, but in this structure, due to C double bond OH, it is an aldehyde. In this structure, C double bond OH containing ketone. Same molecular formula with a different functional group, that is the functional group isomers. Aldehydes, ketones, ethers, alcohols, includingly exhibits isomers. But ether and alcohol, there must be a one unsaturation. It is unsaturated ether, it is unsaturated alcohol. Let us see this molecule. It has also 3 carbons, 1, 2, 3, containing hydrogens 2, 3, 4, 5, 6 hydrogens and 1 oxygen atom. See, it is also both has same molecular formula but different functional group. And let us about alcohol, C3, H2, 3, 4, 5, 6, O. These 4 compounds has the same molecular formula C3H6O. But one of the structure is aldehyde, another one is ketone, and ether and alcohol, including functional group isomers. And next one, metamerism. Metamers. Metamers are the chain structural position including structural isomers. So I am taking this compound and another compound is this one. First compound has 5 carbon atoms, and to the functional group left side 2 carbon atoms, ethyl, right side also 2 carbon atoms, ethyl, with the same molecular formula. It has a molecular formula CH3, CH2, here just C, here CH2, CH3 groups are present, and here also CH3, CH2, CH2, CH3 groups are there. For this functional group, left side is methyl group CH3, and the right side 3 carbons propyl groups are present. Metamers are the isomers having same molecular formula. Here 1, 2, 3, 4, 5. 5 carbons are there, and here also 1, 2, 3, 4, 5 carbons are there with same molecular formula. But this functional group has here both side ethyl, whereas in this compound functional group has one side methyl and other side propyl. Different in their alkyl group bonded to functional group are called metamers. That's why ketones only exhibits metamers, but aldehydes cannot exhibit metamerism. And this is about the exhibiting of isomers and aldehydes and ketones. And next one, preparation of aldehydes and ketones. Aldehydes and ketones. For this preparation, first preparation is from alkenes. From alkenes, this reaction is ozonolysis reaction. It is ozonolysis reaction. In ozonolysis, there is a unsaturated compound. To this unsaturated compound, it is react with ozone followed by zinc and acetic acid, gives the products. So about the products, we can write the product in ozonolysis. Break this double bond, add both sides one oxygen. This CH2 part, by adding one oxygen, converted to CH2O, that is formaldehyde, and this part also converted to CH2O, formaldehyde. These are the products obtained in ozonolysis. In ozonolysis, I am taking CH double bond CH2 with the same reagent, and here also basic rule is break this double bond